Welcome to Make Me Data Literate, the podcast that makes data intelligible from the Australian Data Science Education Institute. We're on a mission to make the whole world data literate. I'm your host, Dr. Linda McIver, and every week I'll interview someone with a wild and wonderful relationship to data. Let's see what we can find out. Hello, and thanks for joining us for another episode of Make Me Data Literate. This is a different one for me because I'm actually getting to interview one of my former students, which is a bit exciting. And verging into the topic of bioinformatics, which is a whole new field for us. So, welcome, Michael. Thanks for coming.
Good to be here.
Tell us who you are and what do you do?
My name's Michael. I'm a software engineer at the Centre for Population Genomics. We're an organisation that sits under the Murdoch Children's Research Institute and the Garvan Institute from Sydney. And we kind of fill this pretty interesting gap in population genomics. Is split between rare disease and the population side. And I'm sure we'll talk more about it as we go.
Sounds great. I'm really looking forward to this. Let's to start with. What did you have to learn in order to do this job? And what was missing from your formal education? Obviously, nothing from my subject, but
yeah, so I had a pretty interesting track of how I got to becoming a software engineer. I started like learning to program, kind of year 9, year 10, like a few people do. Took year 11 IT, which was with you, Doc, which was heaps of fun. And then I studied university IT in year 12, studied computer science, maths and physics at university, but worked through my whole degree and actually worked through my year 12 as a software engineer. So I had like fairly good experience across like technical computer and computer science skills. And then when I was very fortunate out of uni, I started working at the Peter MacCallum Cancer Centre, and they were very kindly taught me a lot of the genomics and genetics that I needed to do to be able to accomplish the role. And then switching across from cancer genomics to rare disease was fairly similar. So a lot of like on the job learning around the domain that I was working in, and a lot of technical knowledge I built up just through working as a software engineer. And then the computer science stuff was really nice just to have in the background. Um, Thankfully, no, it's like super formal, like on the job, like having to train, but being able to pick up most things implicitly.
the whole domain knowledge side of things is really interesting to me. I've been creating data courses, and we often tend to teach data and computing as domain independent. But it seems to me, and certainly this is the way I teach, that you can't do it properly unless you know the domain, because you don't know enough about how things interact and what things mean, and you can't do a meaningful amount of data science or even meaningful software development unless you really understand the domain. What's your take on that?
It's interesting. I think software engineers bring a certain like engineering focus and a set of practices to specific domains. And you see like describe bioinformaticians. I would probably tend to describe them as more biologists with a level of computing rather than computers, like a software engineers with a level of bioinformatics experience. I think like both are kind of unique and interesting in their own ways. Certainly, like if you want to do methods development or algorithm development, then you need to have like quite a high level of domain expertise, unless you're extremely niche and can be taught within there. Um, I kind of like being the software engineer side from the software engineer side because I find it a bit easier to switch domains. So like going from I was school management before, and then I've done a bit of basketball management stuff, and then now kind of in the genomic space, I quite enjoying being able to uh, bring the engineering side to these different domains. Obviously, paying a decent penalty for switching domains each time, though.
How much do you feel like you had to learn? Like, were you really, did you feel massively ignorant, or did you feel like you could start to contribute straight away each time you shifted?
It's probably a level of overconfidence coming straight out of university. But yeah, certainly a large penalty for switching, and it has taken a long amount of time to really kind of get my heads through all the different pieces that we do as a center and that we did at Peter Mac to become more confident and actually be able to like contribute positively to the conversations, but without like just the engineering side.
Yeah, I think that that domain knowledge side of things is a neglected part of the software engineering education process, and computing and data science as well. Is there um is there one thing you wish everyone knew about data?
Uh, I think how easy it is to be manipulated, um, and the stories it can tell. Like, I mean, obviously, I've read your book, and there's some great examples from your book that how to manipulate data. But yeah, I think in the end, it is very domain driven. Like things that like are kind of hard to teach domainless or contextless. Like genomics is interesting because kind of any situation as possible, rules exist with as many exceptions as they bring, and and other domains as well, like fluctuations in like weather measurement machines might be easy to predict in one domain, but not in another. So I think that the domain is an important part of that.
I think that whole that idea of how easy it is to manipulate things, and that you need to understand the context of the data and the domain of the data is really important. There was a study recently. I'm not sure when it came out. It might have been as long ago as 2018, but it's been doing the rounds lately of a study that shows that parachutes don't make any difference when you jump out of a plane. And the kicker, of course, is you go and read the study and you find the plane was on the ground. Um, they weren't jumping from up in the air; they were jumping off. And it's an object lesson in actually going and reading the study and making sure that you understand the context. And but there's a that ability to go, well, hang on, what's the catch here? What are the
Yeah,
caveats?
yeah.
And what's actually going on? There was a study I saw recently. Actually, my husband was telling me about it, about that there's no difference between 50 hours of supervised driving for learners and 120, because in New South Wales they increased from 50 to 120. They found there was no benefit to that increase. This study found it. And my first thought was, when did they study that? Was it during lockdowns when there was no one on the road? Or
Mm,
is there something around the context of that study that would change the the
how important or
outcome
useful it is. Yeah.
if you fed that in? It's like, oh, we look at emissions for 2020 and we compare our emissions now. That's not a sensible comparison, because in 2020 most of the world was locked down. So
I
it's
think one of
all of
my favorite
those kind of.
examples was I saw a Facebook headline and it was like dogs are smarter than cats, and I was like, "Phew, that feels like a headline that I'm interested in working out exactly what happened." And you like dig down and you have like the Facebook headline, and then you have the news article that it was kind of written on, and then you have the like the public like the piece that the university put out about the study, and then you find the study, and it's like, oh, all the study was trying to show that it was like the neuron density for animals follows like a rough trend or something like that. And I mean, they showed two animals of each species, and it's like, yes, dogs have like more neurons on average than cats, and it's like, yeah, but neuron density or amount of neurons is sort of a bad metric for evaluating how smart or intelligent an animal is. And I was like, oh, I'm glad I like deep to drove down in this, but it does make for a good headline.
Yeah, it's a problem, because there's this insatiable drive towards clickbait over content. And so we'll do a headline that gets people clicking, and doesn't actually matter whether it's misleading or not. And half the time the only thing people see is the headline, and so they come away with this wildly inaccurate understanding of what's been found. And half the time nothing's been found, but they put a press release out anyway. It's a problem. What are some of the worst data mistakes you've seen?
Worst data mistakes I've seen. No, like clear, unique examples or like novel examples really come to my head. I mean, you have the classic, like the perception problem where the planes were coming back and the holes were in all the places where planes could survive. I see a lot, like I mean, a lot of it is sometimes shared by you, but bad graphs, bad interpretation of data, um, kind of setting up arguments in not bad faith, but maybe misinterpreting data to give one outcome where that's like not that's not necessarily the case, or it kind of can make the case for both sides.
Are there any
Um,
traps you find yourself falling into sometimes when you go, "Whoa, that's not I shouldn't have done that," or "I shouldn't have, believed that."
um, I mean, definitely like the who. Uh, like the obvious outcome, or the outcome that like someone is trying to paint with the data, like
Mm.
isn't the always the case. And sometimes I have been walked down that hole of like, this is what the data is and this is the story that I want to tell. I'm like, oh yeah, that sounds like quite reasonable. And then it comes out like a little bit later that that wasn't the case, and it was kind of misled or in some way or another.
Yeah, there's so many ways to get tricked and trapped, and I think the worst ones are the ones where we trap ourselves. You know,
Mm.
we want to believe something, and we want to find something in the data, and so we
Yeah.
look really hard until we find it, and then kind of, it's not a consciously we made this up, but it's a, we pushed too hard to find something that wasn't really there.
Yeah, it's a lot of the classics like chocolate decreases chances of Alzheimer or something by 20%, but it's gone from like 0.001 to 0.0008 or something. And it's like, okay, maybe in that study there was a lower incidence, but doesn't necessarily mean there's a causation, or doesn't mean that the effect is actually meaningful either.
Yes, that I often find myself being swayed by statements of change in risk, like,
Mm.
as you say, 20% decrease, and then you think, hang on, what was the starting point? Is that
Yes,
actually
yes, yes.
meaningful in any reasonable sense? Should I not eat bacon? Should I not eat butter? Should I, all of those.
Yes, yeah.
It's interesting. Terry Pratchett had a line that a lie can run around the world before the truth gets its boots on, and I think that's really true of these kinds of research findings. That the plausible sounding ones, or the ones people want to believe, like red wine decreases your risk of heart attack. I really want to believe that one. you know? So those ones, they spread,
Yes.
before they've been properly evaluated, shall we say. Some of them never get properly evaluated, I think. Um, have you ever seen data deliberately misused?
I think like we see some interesting cases in genomics. People maybe trying to pull out meaning where there isn't necessarily some. There were some studies the other day that maybe evaluated. I can't remember the exact details, but probably I shouldn't say it. But they evaluated maybe intelligence, and then they did like broad sequencing, and then you can kind of pull out correlations with anything, right? You can find maybe specific genes that in this one study correlated with an increased performance on some test. um, but then it's very easy, like it's kind of those follow on headlines, right? It's like you might say that this gene is, well, I mean, you can't even show causation, but it's hard to show causation, but these headlines very can quickly turn to like, this gene makes you smarter, or like even delving into kind of ancestral based arguments as well. For is sort of a dangerous territory to run, and you see it a little bit, and there's some lot of ethics that some organizations sort of place, and they try to sort of maybe censor or not look at this information before it goes out, because they're conscious of the implication that some people might take away.
That's always a risk in science when people are looking for particular outcomes, and you can find maybe one correlation that supports the outcome that you want, even though there are 15 correlations that that
Or
show the
also just
reverse.
search broadly for everything, and then just find wild causations that maybe aren't or maybe are statistically significant in the experiment, but don't have a good correlation, like a good grounding in science.
Yeah, I feel like all researchers should have a compulsory course in the spurious correlations website.
Yeah.
Just look at all of those graphs. That if you haven't Googled that, you should Google that, because spurious correlations is a wonderful website. It shows things like correlations between consumption of margarine and death rate, I think, and Nicolas Cage movies with, I don't know, car accidents or something. Like, it's really these weird and wonderful correlations that, and the graphs look really plausible. But that's my PhD. One of my examiners sent it back with a note on one particular section saying correlation is not causation, and I was really ashamed of that post-it note, because I knew correlation wasn't causation, but I'd made that. It's really hard to avoid making that link to say, well, this happened, therefore, rather than the two happened together. Um,
I mean, we're good pattern finding machines.
yes, yes, we are. It's one of the reasons I think we're falling for ChatGPT as a sentient entity, because that's what we want to see, and that's it's a pattern that kind of exists there, even if it's misleading. Um, have you played with ChatGPT at all?
Yeah, I have. I've really it's been interesting to follow the rise in different transformer models or diffusion models over the last year, and I mean I'll say openness in quotation marks of OpenAI. I think like certainly some things around them actually publishing the stuff that they find and doing, making these models available to everyday people, which is interesting because Google come out and say like, oh well, they actually contributed like significantly to the research on transformers, but hadn't publicly released any transformer models until a couple
Mm.
months ago. So quite interesting. It's like, oh, we had this, but we didn't make it available. Where OpenAI, obviously as an organization, are making them so that everyone can play with them. I think more so just makes me feel that people and a lot of what we do is just one giant statistical generator. Just can we guess the next word that comes out? um, and interesting to see like the different models that are good at certain things, and you see like the compartmentalization around the brain as well, doing these other things like a text center or an image processing center, and how they're geared up for kind of these different base things. It's been really awesome to follow, and certainly integrating like Copilot into some of the code that I write, and seeing where it falls over, and seeing what it does really well, which has been really cool. Um,
Do you feel like it's
and
been a net positive using Copilot?
Yeah, I think so. It takes some of the tediousness out of writing code. Some things that are just like basically I just need to duplicate a class definition or write some documentation. Well, at least prompt me to start, so I'm not kind of sitting there like waiting for that first word. I can just take what's there or revise it and be like, oh, it's actually pretty good. It's pretty close to what I wanted. Probably spend a bit more time just checking the code, which can be a bit more exhausting. But yeah, can definitely help speed up some actions pretty quite high.
You spend the time checking the code. What I worry about is the people who don't.
That's what tests are for.
Yeah, yeah. I think
Until
this
Copilot
whole
writes the tests.
Yeah, then we've got problems. Um, I was talking about that with a friend the other day, actually, about that. When the AIs are starting to um, train the AIs, and so you have supervised learning, but it's actually one AI training another AI, and does that mean the bias then becomes suddenly orders of magnitude increased, or can they detect it? Like, it's really tricky.
It's an interesting What We Owe the Future book. Was talked about this as well as the value lock-in that you get if you have these artificial generalized intelligences to that you're stuck in the morals of today, right? If you talk about like if you wrote an AI say 100 years ago and you saw a value lock-in 100 years ago, it's quite a dramatically different society, and those lock-ins can happen for quite a long time. So making sure that biases aren't there, and making sure that like this AI or these intelligences can adapt for changing morals is going to be really interesting.
Are
In fact,
you
I just thought of more examples of the Amazon book, the book about like the Amazon starting, where it feels like they had this clear like data point or something, and they just misinterpreted it or interpreted it in a way that I thought was interesting.
the you keep using the word intelligences. Do you feel like
Yeah.
they are intelligent now?
I mean, it depends what you think of it, or it depends what you think of humans as well. I think more so it shows like we are just like big statistical generators, um, and it's probably showing that like maybe we aren't as special as we think we are. There's not some like absolutely innate or crazy about the brain. It's like it was just structured in a way that like language and ideas represent fairly well, and even variance between people, right? And variances between these large language models is interesting. Some seem to represent some types of information a lot better, or you can quiz it, or maybe some are better for context driven. I read an article this morning around someone basically within the 32 kilobyte context you can give GPT-4. It's like you can teach it like a made up children's language and get the language model to speak in that, um, which is kind
That's
of
great.
cool. Or it'd be interesting to see how these are regionalized as well. These models use kind of the prompt engineering to modify the response or modify the input in a way that kind of sits well with the laws and ethics and cultures of different places.
Yeah, that's the interesting thing, isn't it? When you say talk about trying to teach these systems ethics, and then you have to say, well, whose ethics? Because
Mm.
mine are different to yours, and very different to say Scott Morrison's. It doesn't appear to have any. You know, the question of who makes these decisions is an interesting one. I've been looking at uh, the different chat programs. I finally got access to Bing this morning, and asked it some of the same questions that I've been asking ChatGPT. And for a big chunk of the morning, I was asking ChatGPT to write my bio, and it would write it differently every time, and it sounded 100% confident, and every time it was 80% wrong. That I was I'm going to sift through it and kind of figure out the themes, but my PhD was always at a different institution, never at Monash, which is where I actually got it. Mostly in Queensland. ChatGPT is very keen to think I've lived in Queensland, which I never have. Um, but it just kept doing this. It would make different stuff up every time. I had a different job in a different organization, and I had different experience and different specializations. Like, it was almost random.
'Cause I know you've
But I
talked at a
asked,
few conferences, but has anyone at the conference got your bio perfectly correct, or there's always a little bit of play to it?
oh, they always copy my bio from my website. So
Oh,
yeah,
okay.
they get it completely right. It's like they always ask me for a bio. I give them the one from the website, or they just take it directly. Like, it's there's a couple of different variants of the bio there, but it's just differences in wording and emphasis. It's there's no one's ever stood up at a conference and said that I got my PhD in Queensland. um, but then I asked Bing to do it, and Bing uh, took my bio from the web, which is what you'd expect, right? It did reword it a little bit, and a couple of times the sentences just kind of finished. It was a bit weird. But then I thought, okay, so Bing has different behaviors and actually goes and searches for stuff rather than just making it up on spec. So, what if I ask it to find me a gluten free restaurant in my suburb? And it found me a cafe that I knew about, but that I'd given up on because it didn't have much in the way of gluten free. And it said it has a separate gluten free menu, including burgers and something else. I was like, oh, man, I love gluten free burgers. And so I went and looked at the cafe, and there was nothing on the website about gluten free burgers. Like, what? There wasn't even a separate gluten free menu. But the thing Bing does that ChatGPT doesn't do is it provides links to references. So I
Ooh,
clicked on the references,
explainability.
and it took me to an entirely different cafe. So I'm like,
In your location or in your area?
I across the road from the one that it thought it was telling me about. But it's just like these things are designed to sound plausible, not to be true or not to be
I
accurate. And
I think it'd be interesting, right?
I have issues.
And to me, this is the various types of AI that might not be working in the like. Try a large language model is not like it's not bad at holding facts and being able to like
Mm,
reword facts, but that's not really like what it's great for. Where like you could have like different databases of facts that it could look it up, right? Like Bing and Google Maps have like clear like structured data around open times for restaurants and things, and like
mm,
asking like the statistical like language generation around the opening side of a restaurant. Like if you didn't know, like, oh yeah, 9 o'clock sounds reasonable, but like these things aren't uh, like I see like the room for integration, and ChatGPT is starting to do that integration with like Wolfram Alpha and like I
mm,
think even yeah lots of different places where like that's where the really cool bit is, right? I mean there was the thing a while ago that Google were doing was like you ask it at an opening hour like on Easter Friday or Easter Monday or something, and Google's like I
mm.
don't really know, but I'm gonna call the restaurant and I'm gonna parse that text out, and then I'm gonna put that make that available for everyone. And like the controversy at the start
Wow.
was like you couldn't tell whether you were actually talking to Google's bot or not. So I think they added some stuff like, "Hi, you're talking to like the Google Voice Assistant, and we're just trying to check what time you're open on Monday, the 10th of April, or for Easter Monday." But like that's really cool, right? You have like lots of different interactions. In a way you can actually protect the restaurant against like lots and lots of calls. um like that's where language models seem really cool to me. Like the if I think one of the original intentions with that was Google's like, oh, we want you to make like a hairdressing appointment in our system, and then like doesn't have a clear like an API for it. It's like we'll just call the restaurant, and like the large language model and like with enough tokenization you can kind of parse and give all that information back in that like human interface. um so interesting to see all these things connect up in the future.
Yeah, it's going to be interesting to see how it all falls out. What worries me is the people who are using it as somebody told me the other day, "Oh, it's a great research tool," and I'm like, "Have you
Oh
actually?"
yeah.
I mean, oh boy, that's if you used it as a research tool, you found out that I had the Eureka Prize. I do not have a Eureka Prize.
I think something that's also fallen over is the time. Like it's very good for representing state of information, but doesn't necessarily understand like across time. Like for
Mm,
novels, if you ask about books, so the
mm.
changing information it doesn't seem to do quite well. But I mean, these things are just like you find the flaws in it, and you work out the boundary of where these models are really good, and then a couple of years later, someone will work out actually there's a better model for this specific type of thing, and that we like as long as we can integrate them in a way, then get the best of both worlds.
Yeah, I think there's an educative bit missing where the companies are releasing them as sort of, hey, this is this awesome tool, and yeah, sure, the websites say, this is AI, the results may vary, kind of disclaimers, but
Mm.
we know that people believe the results of computers even when they've been told that they're wrong. Like there's this, we have this blind spot where computers are accurate and therefore they're always right, and it's
I mean, that must
it's
be cultural though,
there's a
right? Like
big risk there.
you can unwind that cultural, might take a while, but it should be
That's
possible.
part of my job, so hopefully it is possible. um, what do you look for? You were talking about figuring out the boundaries and stuff with the chat systems. What do you look for to spot mistakes and deliberate misinformation and things like that? What are your go to kind of? Oh, I always check this, or I always look for that, or that's a big tell.
I mean, it's the like I hate to say the classic like follow the money, but I mean if there's someone has a like a reason to benefit from the narrative, like it's always a good signal to be like, let's just double check that, and maybe they're like blinded by their own bias and searching for information. Um, that's usually good. Like I mean, clickbait headlines, interesting to see what fuels them. But it's challenging, right? It's like it's very difficult, and as you said before, it's easy to kind of fall into your own bias, especially when the thing you're reading agrees with the model that you have in your head.
Yeah, that's the big trap, isn't it? Confirmation bias.
Yeah.
Is there something that you ask yourself if you look at a graph in the media? What do you look for?
I always look for the axis. Always look for like where the axis start or where it ends, and bar charts where such a minimal difference between at the top, or like a non-zero axis, or what timeline are we actually looking for things here? Is usually the first things I look for,
Yeah, that's the classic, isn't it?
or
The
sample
the
size.
axes. Yeah, sample size is a good one. Yeah, and often really hard to find. And I think that's
Really
where,
hard to find.
if you can't drill back to the source, then I don't think you can trust the information. If you can't get back to that information, if you can't find out what the sample size was, or where the data came from, then there's big questions around that
Yeah.
result.
I mean, like
Um,
scientific papers are generally like very difficult to read, and they're not like supposed to be broadly applicable and just kind of part of your domain knowledge problem. But yeah, research papers being hard to read, not formatted like super consistently, especially between journals, and certainly
mm.
makes all that harder to interpret.
Yeah, I've been reading a couple of research papers today, actually, and I'm looking at the format and I'm thinking that format was laid out for paper journals in the 60s and 70s. Perhaps it's time we move to a format that's more readable online.
Yeah, yeah, for sure. I don't read paper journals. I only read PDFs, and sometimes the 3 column layout with like figures in the middle definitely makes it
Yeah,
challenging.
yeah, that's what I was looking at. Is the It was a two-column one, but still, it was obviously formatted for a paper journal and really awful to read online. Just terrible.
If only everything was just LaTeX and your browser could render it on the fly, however you want.
Yeah, you're triggering some PhD trauma for me there. I was never a fan of LaTeX. I like what you see is what you get kind of systems, except that they're
Ooh.
never actually quite what they claim to be.
Move a picture around and your whole Word document gets reformatted.
Yes, I'm not a fan of that. That's also there's a lot of trauma triggers there too. There's a reason whole PhDs are written on formatting documents. Is there anything that excites you about data?
I think the scale is really interesting, especially at the moment. I mean, what's the 2023? We went to Sci 2012, and just like when they were talking about like terabytes of data being difficult to move around and petabytes being like approachable. It's like now petabytes are extremely approachable and exabytes are storable. But I mean, petabytes are transferable, but difficult, challenging to move around, and just the cost of storing it is decreasing so quickly, and the amount that you can actually compute with is crazy. And um, a lot of these I feel like a lot of problems in the past have been compute boundaries. Like we don't have the compute, or it's actually, it's you can't store that much data. Whereas like now you kind of can, and you can throw like quite a serious amount of compute, and there are specialized hardware as well that you can kind of write your analysis in the right kind of way, and you can seriously compute a chunk like petabytes of data for an individual analysis. I can't remember how much ChatGPT or Stable Diffusion, but they're not small data sets. Like they're massive, massive chunks, and like it's an organization that's provided it for free. I mean, there's obviously seriously money behind like Microsoft and other institutes that are funding it, but yeah, that's been the crazy thing for me is like what data seemed used to seem enormous ages ago is really quite practical. Just the size of micro SD cards as well.
Yeah, I remember the SD cards in your camera when we went to supercomputing in 2012, and they would have been pretty different to what you can get these days.
Yeah, yeah. Getting like I think the terabyte micro SDs, I was like, whoa, that is seriously dense.
Yeah, well, Pawsey Supercomputing Center has just upgraded their system, and they've got something, some massive increase in the compute power and a massive decrease in the energy use and in the physical size of the system. And So it's just you get more for less all the time.
Yeah, really cool. And as software engineers, it's just our goal to not become lazier and write less efficient software and make it as efficient, if not more efficient, so we can do even more with the cheaper compute.
Well, there's been a lot of talk about the environmental cost of computing, especially in the context of training these large language models and stuff. Is that a consideration at your work, or is it all just head down on the data and figure the rest out later?
Uh, we mostly head down the data. I mean, the not so much the environmental, but the economic cost on an individual level is quite high, and um, these are expensive questions to answer, but they're also extremely valuable to participants when they get them. I mean, that's what funds our center, and um, yeah, I mean, I didn't talk too much about our center, but we have a large part around improving the genetic diversity of like these large population databases and giving better health outcomes for underrepresented ancestral groups. It's like a high economic cost. There's a high environmental cost, but absolutely worth it for improved health outcomes and just more knowledge that comes as well. It's kind of difficult to pay a knowledge and outcome versus environmental, energy, or economical cost.
Yeah, it's a tough calculation in many different contexts. This idea of improving the diversity of the databases. Why does that matter?
Yeah, so um, uh, biological pathways in people are not created equally. Is probably and it kind of goes back to that for every rule there's an exception to the rule that just seems to work, right? But I mean broadly, people don't work the same, and even particularly across ancestral groups, people's bodies just work in different ways, and one medication that might work for people like Indigenous Australians might not work for Indigenous South Americans or so on, and like yeah, different biological pathways, different biological mechanisms, and just the more information that you get around what genes are important for specific biological pathways and how that gets activated or deactivated improves the health outcomes to everyone as well. So it's just not like researching or finding about more about like Indigenous Australians. It still has positive health outcomes for everyone because you just kind of work out like this pathway, this is the way we think that it works, but you actually know it's like, oh well, that they people don't have that gene, or that gene is different for other different people. How does the mechanism still actually function? Because it doesn't seem like it should function. You might like have a turn off over here and a turn on of a gene over here, and suddenly like everything kind of works hunky dory. One of the craziest like the intersex disorders that we see at work. So, like multiple different combinations or copies of X's and Y chromosomes. You can have, I think it's the SRY gene for males, which drives a lot of like the development of male organs. That you can actually have it translocated from a Y chromosome onto an X chromosome. So you can have someone
Oh
that
wow.
is double X chromosomes, but phenotypically, or like so the presents as and has male organs. So even like these rules, right? They're not clear rules either. Even if you want to try and define someone by their karyotype.
I often call myself a professional outlier. So if there's a way something can behave differently, that will happen for me. So I find this work particularly important.
It's
Describe
crazy. It's so
the
interesting.
outliers and the exceptions and the different cases.
Yeah, definitely
It
makes
fascinates
dealing with
me.
those cases interesting.
The textbook presentation of sort of anatomy and physiology and even genetics is it's a lot like my criticism of science education in general, that we present these things as facts and known processes and we don't look at the complexity of them in the real world. And um, I have a friend who went in to get a pacemaker, and they had to reschedule the operation. They had to stop and do the operation another time because they found that his arteries were plumbed differently to everybody else's. Like they're just, there was something that went up when should have gone down, or was plumbed. They just, these things happen. People. There are people who have their heart on the right instead of on the left, and we're not set up to kind of manage that in our understanding of medicine. I think we tend to think that people, behave in the same way, and just bodies are complicated. I went to a specialist
Yeah,
recently who
I think
said
for sure
nerves are weird. They just don't always do the same thing.
I think like in the past, it definitely made sense to have these like simplifications, and you see it in lots of different domains. And this is the data thing, right? When you have more and more data, and you can safely and well less invasively like explore people's bodies and work out biological pathways and all these things, like this information becomes a lot better, and once you understand the underlying mechanic, and these things are a lot better. That's where AI will probably help a bit, is being able to conceptualize some of these things or simulate them in ways that are much less invasive than cutting someone open, or growing your different models on growing your different models and trying to explore it like that. Um, and you see across different domains, it seems natural that it'll happen to medicine as well. As like now we find lots of examples, and we notice the diversity, and we try to come up with better techniques for learning and managing that, and becoming more aware that things are different across different people.
The idea of personalized medicine is starting to become meaningful.
Yeah, yeah, and it was big at Peter Mac, right? And I mean, particularly with a cancer focus, not all cancers are the same. You might have lung cancer, but there's lots and lots of different types of lung cancers, or you might have the same type of like phenotypically driven lung cancer, but underlying the biological mechanism is completely different. So one drug might work for you, might not work for someone else. Um, but that personalized medicine is, you can look at the tumor, you can actually like physically look at the somatic um, uh, like signature for the cancer. The signature for the cancer, and say like, hey, it's like driven by that gene, and if we can deactivate that gene with a medication that is like harmless to the rest of the body, then hey, we can stop it. And there have been some studies last year as well. There was a drug that I think that the study size was I think around 12 to 15, and I think they ended up shutting down the study early because it was unethical to continue with a control group given the positive outcome of the
Wow.
medicine. So it seems and there's more data, right? More data and smarter ways to crunch it, and better ways to model information is leading to really, really positive health outcomes.
That's really awesome. And that's a good place to sort of wrap it up around. What excites you about data? Well, it might save our lives. Thank you so much. That was super interesting. Great
Yeah,
conversation.
always great to chat. It's certainly interesting. Data is very interesting. The problems that come with it, and how we as like scientists or software engineers or people in the general public interpret and interact with data is definitely very interesting.
And needs a lot of work. Thanks, Michael. That was great. Thanks for listening to Make Me Data Literate. You can support the work of the Australian Data Science Education Institute at givenow.com.au/ADSEI. Tune in next time for more conversations with amazing data experts.